So yeah, I'm going to talk to you about recent developments that we made together with Evosep to develop a new gradient for the detection of a really notorious synthetic anabolic steroid, which can be used also for other steroids and other hydrophobic compounds. So here is how I'm going to organize my presentation. First, I'm going to present our laboratory, and then I'll show some out-of-the-box adaptations, and then we'll go deeper into doping control analysis. With the development of the specialized hydrophobic gradient, then I'll show some high throughput LC strategies comparison, and then we'll go through two case studies of detection of stanozolol and its metabolites in equine urine and equine hair, and then we'll have a conclusion. So the LCH is almost 50 years old now. It began in the early 70s, and now we are located since 2003 in Verrières-le-Buisson, close to Paris. It's a ISO 17025 accredited laboratory for horses, jockeys, and camels. It's also a FEI and IFHA reference laboratory. And for numbers, we receive almost 30,000 French horses samples per year and 7,000 samples from horses outside of France. And this is summarized as 300,000 LC or GCM SMS analysis per year. So there is quite a significant amount of samples. For this, we have 65 permanent employees and 10% are dedicated to our R&D. And of course, we use a lot of liquid handling platforms to do all these samples. We have numerous LCMS and GCMS, but also one ICPMS. And for LCs, we have numerous UHPLCs, but also 3 ion chromatographies and 2 nanos. We have also one molecular biology unit, which is dedicated to gene doping and biomarker monitoring. And of course, we have one Evosep One, which is coupled to QXHF. So when we received the Evosep One, of course, we wanted to adapt directly some of the proteomics-based method that we had. And the first one was the detection of recombinant human EPO, which is based on the detection of the 2 specific peptides that are highlighted here in red, which are different from the equine EPO. So by detecting those peptides, then we have a clear detection and specific detection of human EPO inside a horse sample. And here, as you can see, the 2 chromatograms obtained on an Evosep One, which are detailed further in this application note. We also adapted some other protocol, which is the quantification of somatotropin or growth hormone. And as you can see, the Evosep One is pretty efficient for quantitative analysis. But as you may be aware of, we are not only targeting protein-based drugs, but in fact, it represents a really little portion of our analysis. And we are looking for numerous drugs from the pharmacopoeia, but also illicit drugs and black market products such as experimental drugs or designer steroids. And as you can see on this on those figures, we are dealing with lots of chemistries, and some of those are crazy, such as this one, which is highly hydrophilic, and this one is highly hydrophobic. One of those class of compounds, which is really notorious, is steroids. And if you don't know why people are taking steroids, then I just suggest you to Google this on Google Image, and then it's going to be pretty obvious. Steroids is a really big family of compounds, and it includes hormones, sexual hormones here, and also synthetic steroids, which we are targeting. And those are strictly synthetic, so it should never be in a biological sample. That means that it's brought from outside, which means that we have to have the highest sensitivity to detect them. And the most notorious one of those synthetic steroids is stanozolol. So why is it so notorious? It was 88 when Ben Johnson won the gold medal at the Olympic Games and then had to give it back because he was controlled positive for stanozolol and got banned for life. And it may be old, but not so old because anabolic agents is still the most reported class of compounds in the WADA. And the first one in this class of compounds is still stanozolol, so it's still being used and it's still a considerable threat. For horses, we had also numerous striking cases over the past few years, so it's also a threat for horse races. So how do we detect the stanozolol? Usually we use to perform UHPLC separation. We are targeting stanozolol, but also its metabolite hydroxylate in here. And the method is really robust, also sensitive, but we were wondering, of course, what can the Evosep One bring us? Can it bring sensitivity or robustness or both maybe? So we are going to try to find out. So of course, the first thing to do was to perform the injection of those compounds, metabolites, and stanozolol with the already available method in the Evosep One. And as you can see, it's not really satisfying because everything is eluted at the very end of the gradient, but also peaks are tailing and are not really satisfying. And it's not a big surprise because the Evosep One gradient is specifically designed for proteomics. So we asked Nikolai for help and he helped us to develop a new gradient. So basically, when you develop a new gradient on the Evosep One, you have to change every flow rate of the 4 pumps. It's not just like putting a percentage of acetonitrile at some time point and then it's going to be okay. You have to think of every flow rate of every pump at every moment and then translate it into 2 gradients, one that is happening on the tip and one that is happening on colon. And this is the gradient that we developed. So it has quite different slopes and it's more efficient for hydrophobic compounds. So now by injecting the same mixture, then we can see that the compounds are eluted earlier, but also peaks are now better shaped. They are now raw, and also raw intensities are higher, which is interesting to get more sensitive detection. So to evaluate the performances here, we perform multiple extractions of urine spikes where stanozolol metabolites were spiked at a given concentration, which was the reference from literature. And then we perform the extraction in equine urine, which is particularly complex. As you can see here, it's really heterogeneous and non-sterile. So it's a real nightmare to extract, but still it's working. So we insert internal standard, we perform enzymatic hydrolysis, and then we extract those compounds using mixed mode SPE on the robot, and then inject it on your gradient. And to perform the technological comparison, we compare it with what we used to do in the lab, which is UHPLC, but also with microflow LC, which is having a really big hype right now in the proteomics area. So as speaking about robustness, you can see here that the Evosep One is performing quite well because it's the data points that are detected are contained within the tolerance window for RT deviation. Microflow and UHPLC are performing better, but that's not a surprise because you can't really beat those guys on robustness. By using an internal standard, so relative retention time deviation, then this phenomenon is quite lower for the Evosep One, and it's just really robust. So that was a minimal compromise made on robustness. What is more impressive is the gain obtained on sensitivity, because you can see here on the left the chromatogram obtained on the Evosep One and the same chromatogram obtained on the same sample obtained on microflow and on UHPLC. And by zooming in, you can see that we can still detect them, but not quite as intense and as on the Evosep. In fact, this is quantitatively higher. We get a 20-fold increase in intensity and almost 60 between Evosep and UHPLC. So there is a significant improvement in terms of sensitivity, and this is what we were looking for. So to be able to use this kind of approach for confirmatory analysis and eventually positive case report, we have to ensure that the detection is specific and consistent, which means that blank samples should be free of any transitions or any chromatographic peaks, but also spiked samples should have clear detection. And we tried to set up a new reference concentration, which was 10 picograms per ml. And as you can see here, the stanozolol metabolite is detectable at 10 picograms per ml. When you zoom in, then there is a clear detection of the metabolite. So we can say that the 10 picograms per ml could be in the future a new reference concentration. And the detection is efficient because we can detect these with 3 transition with and also a really high signal over noise. So to continue with these results, we wanted to confirm them with in vivo data. So we performed the analysis of samples which were collected after microdosing doping scheme. So stanozolol was administered to a horse, and we monitored urine for a long time, and then we are going to try to detect stanozolol for a long time. So in fact, stanozolol and its metabolites were detectable up to 90 days, which is a great improvement because the previously reference concentration was 100 picograms per ml. So you can imagine that with the past generation LCs, we were able to see up to these samples, but thanks to this new approach, we are able to get a really bigger detection window. The retention time is stable and the method is robust, even with matrix and in vivo data. And here is a chromatogram obtained prior administration. You can see that there is no specific signal, and 20 days post administration, it's pretty obvious that there are numerous stanozolol metabolites. So we extended the detection window in equine urine. As for hair is really interesting for doping purposes because it has a great power of encapsulation of the compounds. And what we do here to show its power, we split the hair into 1 centimeter section using a hair clipper, and then 100 milligrams were extracted and injected on the Evosep One. So after 1 milligram per kilogram administration, we can get these kind of results. So a blank equine hair doesn't provide any specific signal, as you can see here, and 1 centimeter away from the cut side, so the closest you get from the root, then you can see that the signal is coming out of the noise. And as long as you go further and further away from the root, then the signal increases and the detection is really clear here and there. So it makes sense that the compound was having a greater concentration along the hair. By plotting this all together, then you can see that we can observe the stanozolol elimination of inside the hair. And in fact, if you calculate hair growth to calculate the months of detection, you can see that we can detect stanozolol and its metabolites for almost 5 months. So it's a quite big window to detect it. Here is the previous reference concentration, which was already pretty low, which is 200 femtograms per milligram, but you can see that we have also increased the detection window by applying this method. So the elimination process can be observed up to 5 months, at least. So to summarize, we developed a new Evosep One gradient, which is the, for now, 11-minute method because we want it to be quick. It's robust and it's efficient for the detection of stanozolol and its metabolites with improved sensitivity, but also it provides us multiple month-long detection in complex matrices, which was which we were looking forward to. So with this, I would like to acknowledge, of course, the R&D management team, Ludovic, Marie-Agnès, and Patrice, but also LCH colleagues involved in the project, especially Nasrin, who has been a master student in the lab last year and has done quite a significant amount of work on this project, and also Benjamin, who's working a lot with me on the Evosep One. And of course, I want to thank Nikolai for help developing the gradient. And of course, I would like to acknowledge the funding partners, the EFCE, but also Fédération Nationale des Courses Hippiques, Le Trot, and Le Galop for funding the research. And with this, I take any question, and if you have any.